Hello everyone. So in a previous video we looked at unlocking these Makita batteries and I made this Arduino shield. So I would like to make a more simple version of a how-to guide of how to unlock these batteries. Most of the parts are easily available. So anyway, what we've got is we've got these Makita batteries that sometimes these things get a lockout condition where they will be rejected by the charger and the tool, and more often than not it is just a software lock inside the battery. These batteries have a small microcontroller inside of them that manages the battery and also decides if the battery is able to be used or not. So the goal of this project, we're using a project called Open Battery Information. It's all open source. The tools are very easy to get a hold of, but our goal is to reset the software lock on the batteries so that we can charge them up again. So in order to start off, so we need a few basic things. I mean, they're not very hard to get a hold of. The first important thing, you just need to get one of these Arduino Unos, and these should be available pretty easily off Amazon. And some of these, while not required, I'll go into this in a little more detail, but so in other words, we need to be able to connect in to this, see this connector on the top here? So this is how we're going to connect into the battery and send the battery the reset signals to reset the lockout condition. So we need to be able to connect to these pins inside here. And in order to accomplish it, there are various homemade solutions. There are 3D printed solutions. If you search on the internet a little bit, you can probably find one. But I thought the most reliable and way to do this was to just grab the cheapest charger that I could get off Amazon as a donor, and I'm going to borrow this connector or take this connector off this charger and use this to connect into the battery so that I don't have to mess with a flaky connection to the battery. So I think this was like the cheapest charger I could get, made in China. I probably would not ever use the thing. So this is basically all we need. We need a couple more things. We need a couple of 4.7 kilo ohm resistors, and these are pull-up resistors for the 2 data lines on the battery, and we need these. And for a simple explanation is we need a pull-up resistor because these are open collector data lines, and you don't have to really know what that means, but just know that you need these 2 resistors to make this happen. So out of curiosity, if anybody wants to see what is inside one of these batteries, I've taken these apart before, and I will open one of these up very quickly so that you guys could just see what's inside these things. If you notice, in these batteries there are 4 screw holes, and one of these has a plastic plug in it. And this plastic plug, I don't have one out of the battery to show you, but the plastic plug is just a small, it looks like a small plastic cup and it's shoved in there. The easiest way to get this thing out is to just take a wood screw or a sheet metal screw that fits in there, drill a tiny hole in it, screw that screw into it, and just pull it straight out. And I think that's how I got this other one out. So this is the battery that I have opened. Now you absolutely do not have to open these batteries to reset the lockout flag on these, and I would recommend not opening these if you don't have to. In order to get into these batteries, they have a special star drive type screw, and it's a security bit. You need a driver in order to open those, and this driver, if I look at this, this is a DT, it says DT-10 on it. It says it's a 2.7 millimeter, I think, 2.7 millimeter tool. And if you look at it, if you look very closely here, you notice that there's a indentation in it, and I'll show you the screw once it comes out of why that indentation is important. So if you're all curious, we'll take apart this battery quickly just to see what the inside of this looks like. So I've already removed the plug out of this. This is one of the batteries that I had trouble with and had to unlock myself. I dropped one. Okay, I'm going to show you this screw quickly so you can kind of see what's going on. So you'll notice this screw, it's a little star drive and it has a little dimple in the middle of it, and that little dimple fits inside the hole on this tool. So if you want the proper tool, it's a star drive, and it has the security bit in the middle to take into account that dimple in the middle of the screw. This is the proper tool to open these batteries, and it is also the proper tool to open up this charger, which we'll get to in a minute. So the inside of this battery, if nobody has seen these before. So this is the yellow connector that we're interested in connecting up with, and this is where the power is on the battery. So if you want to check this, so we have our multimeter here. And we check the condition of the battery. This is not really important for this example, but one of the reasons that these batteries get locked out is because maybe they are discharged too much and the charger sees that as a possible problem with the battery and locks it out. So we're just going to put this is where the cells are, so let me take the bottom of this off as well. So this is what the battery looks like inside. It's got for this specific battery, this is a 4 amp hour, 18 volt battery. It has 10 cells. They're lined up in 5 banks of 2 cells each. If we look at this, so this is normal. You don't want to short anything out. Be careful when this thing is open. You don't want to short anything out. There's 20 volts in here with quite a bit of power. So we measure across these, and you see we've got 20 volts, and I've got the leads backwards because there's a minus on there. And we can measure across the cells if we like to. And we can see we've got 20 volts across the entire pack, and we can even measure the individual cells. So we've got 4 volts, 3.96, 4.03, 4.03, 4.03. It is possible to manually charge each one of these cells, each one of these cell blocks individually. It does take a little bit of time, and I did post a video about that, and I will put a link to that video in this description if you'd like to see. It's a pretty time-consuming process and takes several hours to complete. I think it took me probably about an hour per bank to do, so be prepared to take some time. But if you do manually charge this battery for some reason or another, you need to make sure that every cell bank is roughly the same voltage, because if it is not, when you attempt to use or charge this battery, it will probably lock out again. One of the things that this controller monitors is the balancing in the cell, and if they are off balanced, they will probably lock out. Okay, so with that, so I'm going to put this, actually, we'll leave this apart for just a minute. So the next thing I want to dismantle is this charger. And I'm going to leave this battery open for a minute. I'm going to put it back together before we start actually doing anything with it, because it's safer and easier to work with the case on it. But I'd like to show you where the things connect on the charger. So the same idea with this. You need this star drive. And I honestly don't know why the screws are the same. on that this charger, maybe it's made in the same factory under a different brand, and they have the same screw supplies and they use the same screws as the official charger. I don't know, but it is possible because I don't see any other reason to put these security bits on such a cheap charger. Let's see, one's in there. I can't. There it goes. Now I know you can get these star drive bits in like a combo case that has a whole bunch of bits in one, like just the tiny bits, just the heads, and then it comes with a handle. The problem with those is they will not reach all the way down this hole. So I had to buy this specialized driver just because it has the longer shank to fit down the hole to get the screws out, because the shank on the other combo kit that I have goes around the head of the screw and it will not fit into this hole. Okay, so I've had this thing apart many times, so I kind of know what to watch for. But the first thing you'll notice is there are two connectors, at least on this charger. And like I said, I don't know if it's by chance, but these are the exact two same connectors that are in the official Makita Charger 2 that connect the top to the bottom. Like I said, I wonder if this has been made by the same factory. But the only thing that we really need is this top piece. So we're just going to grab each connector and disconnect it. And this piece, we don't need this, so this goes away. There are, and I will remove the bottom of this. This spring-loaded piece is kind of a pain to get back on. Oh, I did not bring the right tool. Just a minute, I've got to grab the driver for that. Always forget something. All right. This is kind of a fun thing to get back in because it's spring-loaded, but I'm going to pull it out to show you guys what's under this cap. So it's these two springs here that are going to be fun to get in because they have to go inside these grooves here and stops when you assemble this thing. But this is essentially all this is. Where did that screw go? There it is. I would like to put this back together when we're done. So essentially what we're looking at is, I'll use this other battery that's still assembled, is these two prongs here will fit into these two long grooves, and then our data line connector will connect into here. It just goes on just like that. Okay, quick note guys, on the video I said that the middle, the smaller bar here, was not used normally except to check the status of the battery. It appears I'm a little bit wrong on that, so I want to throw a correction in here really quick. So when you've got a tool, or I've got this light, so the light here, if we look closely, it connects into the two long bars. So a tool or other accessory that will draw a lot of current connects into these two longer bars. The smaller bar appears to be for the charger. So just to make a quick correction here. So I made a comment about possibly using this for projects, and that probably will not work because of the fact that it connects into the smaller pin instead here, which I think provides a different connection to the battery pack for charging purposes. So I just wanted to add that quick note in just to correct something that I probably said incorrectly. And like I said, I bought this. I think you can probably extract this plastic piece. It looks extractable, but it looks like I cannot do it non-destructively, and I would rather like to keep this thing in one piece. So anyway, this is the only part that we're looking for. And when we connect to this thing, we want to connect on this positive side. And this, actually, take that back. I'm sorry. We will not connect on the positive side. The positive side is not needed for the reset tool. It's just interesting to look at the voltage on the cell if you want to see. We're not going to use the positive side. We'll use the negative side, and we will connect to 2 pins inside this yellow connector, which is broken off here. So if we put the battery on it, and just out of curiosity, we'll bring our tester up and make sure that we're connecting up to the battery, which we should be. There's no reason why we shouldn't. We've got a positive here, the red one, and we've got a black one. We should get 20 volts on here, and we do. And I believe last time, I think I charged this battery about a week or two ago, so it should still be fully charged. I know it reads 18 volts, but when it's fully charged, it's more close to 20. All right, so let's clean up a little bit of stuff here. So there's a couple other things that I grabbed for this. So we have our, let me put this back together. I feel a little safer with it somewhat assembled, if I can remember how to put it together correctly. And this, you'll notice this plastic piece also guards against these metal parts shorting out. So it's kind of nice to have this thing on top because you know these metal parts aren't going to short out in some way. All right, I dropped one of the screws, but I see it on the floor. I will get it later. Just need to get a couple screws in this to hold it together. So there are a couple different versions of these Makita batteries. This one that I have right here, this is a BL1840. And this is actually a relatively older battery and does not actually have the maintenance features inside the battery's microcontroller that these newer ones have. See, this newer one I have is an 1860, but it has a B on it. And there's a different microcontroller in here, and it has some extra features that allow easier resetting of the lockout flag. So these were a pain to reset. You could take a look at my previous videos to see, and there is a solution for these coming out as well. Today, what we're going to go over will not reset this specific battery, but what we're going to go over today will reset these 1860B or any of them from this era. And how you can pretty much tell is they have this battery indicator, level indicator on the back, which this older one does not. Okay, so going over some other parts here. So we have just some wires. I pre-soldered together some wires to save time here, because this soldering these is rather boring, and I don't think anyone wants to watch that. And these are going to be for plugging into the Arduino. I will show you here when we get the Arduino out. Just have one more of these yellow ones. Where did it go? There it is. So we've got these to plug into the Arduino. And then we have some hookup wire too. So I'm going to be assembling and soldering some of these also live here. But not to worry, it's pretty straightforward and easy to follow and not very time consuming. But I did want to do it live here so that we can see how easy, hopefully how uncomplicated some of this is. So let's take a look at the Arduino. So we have an Arduino Uno. This is a 5-volt microcontroller development board. And these have been out for several years now. I mean, gosh, this has been over 10 years now. These are very common. You should be able to get them off Amazon. There are probably some not there's probably some compatible ones that are similar, which will probably work fine for this. But today, well, we're just going to go with the official Arduino Uno because I know that this works for sure. And so that brings up our battery connections. So there is a schematic. I will, when we get over to the computer side, I have a freshly installed Windows 10 computer set up that we will do the software end of this too. So we're going to go through the entire process today. So looking at a schematic for this thing, I have some kind of a pointer here. So we've got two things here. We've got the Arduino, which is here. So this is our Arduino device here. And each one of these blocks here are the connector blocks here. And then we have our battery. Same idea. The battery, this is the top view of the battery. You can see that the battery has this, actually, no, it's sideways. Okay. The battery has this longer connection here. It has a shorter one. The shorter connection is actually used by the tool to check if the battery is healthy or not, or if it's able to pull power from the battery. So that this is not used while charging. And then we have our data line connection. The tool does not use the data line connection either. This is specifically for the charger. Then we have our negative terminal here, and that's depicted in this picture here. Positive, our condition status line, then we have the negative, and then we have these connections here. There are actually 7 pins on this yellow connector, but this charger that I got does not have a wire in the last pin, so we have to remember that and to take that into account. So they have a wire in every one of the slots here except for the last one. So we'll have to remember that when we go to assemble this thing. So with our schematic in front of us, and first thing is let's get the hardware assembled. So we've got our Arduino. We have these 2 resistors. Like I said, these are 4.7. The value is not especially critical. I mean, if you get a 5.6 kilo, you may be able to go up as far as 10K. You might be able to go as low as 2.2K. You're not going to fry this thing if you put the wrong resistor in here. As long as you're close to the value, it's just not going to work, and the communication isn't going to the battery and the microcontroller and the Arduino aren't going to be talking if you got the wrong resistors. So we have these resistors here. We have the Arduino here, and we have the battery here. So this is how we're going to hook stuff up. So the first thing we're going to do, so we have this guy, and if you notice, the battery goes on like this, and let's see if I can do this. I hope this isn't glared too much. Let's see if I can get that glare better or worse. So we have our battery, and the battery is going to fit on the charger, or the charger is going to fit on the battery, one or the other, like this. So if we take that into account, we're going to set this down here just like it were the battery. And now we've got our leads coming out, and we can see easily what goes to where. So for this, like I said, I got this cheap charger, and it's a sacrificial device. I'm not intending to actually use this charger for its intended well, my intended purpose is to take this connector out of it. But so you can just cut these wires off and splice into them if you like. But the kind of person I am is I don't like cutting things in such a way that I cannot put them back the way they were. You absolutely do not have to do this. But these are JST, so these connectors, if you want, you can get a hold of these connectors so that you don't have to irreversibly cut these wires. So this connector here, this is a JST. It's a PH connector. It's got 6 pins. It's a 2.0, I believe 2.0 millimeter. Just look up JST PH. I'll write some details in the description of this video. And I do not remember the spacing on this. I think it's 2.5 or times 2. I think it's 5.08 millimeters, which is, I think, 0.2 inches. But this is the other connector that I grabbed, and it perfectly fits on here. I don't have a brand on this one, but you may be able to just look for a, this is a very common connector used in a lot of electronics on power header pins and other such device parts. So if you want, you can get a hold of these parts. You might be able to find them on Amazon, but they are absolutely not required to do this. I just did it because, like I said, I would rather leave this in a state where I can put it back to how it was. But if you do this, make sure you line stuff up. So black goes to black, red goes to red, yellow goes to, well, yellow. Okay, so the first thing is we're going to look at our diagram, and we're going to route some pins. Okay, so actually let's put some pins in the Arduino first. So in the Arduino, we have 4 pins that we need to connect to. We have a 5 volt, a ground. We have D8, which stands for a digital output or input. These can be either output or input pins. This is going to be a digital IO 8 and digital IO 6. You'll notice they go from 0 to 8. Actually 0 to 8, there's actually 13 of them. I didn't write them all in. So we will put as placeholders that the colors are not important, but I did get the colored wires just because it helps us to keep track of things. If you'll notice, if you look very carefully at this board, they're written on the board and sometimes on this connector as well too. So the other way we can just count up. So if we look, we've got, you go up 1, 2, it's the 3rd and the 4th. So 3rd one's ground, the 4th one's 5. So we count up 1, 2, 3rd one's ground. 4th pin is 5. So you've got those 2 connected. And then we've got one on D6 and D8. So you've got a D7, so it's the 2nd one down. So count down, 1, 2, D6, and there's a D6 printed on the board, along with on the connector, and D8. Okay, so these are the pins required that need to connect from the Arduino into this connector. So the next step, so let's see, what do we want to do next? We can start connecting things up. So let me get the soldering stuff ready and set up to solder stuff so that I do not ruin my table. And the first thing we'll need to do, at least, well, the order is not important, but black to black, you connect the ground into the Arduino. So the easy way to do this is just to strip this off. Strip the other one off. As far as the length of these wires go, we are dealing with high-speed, kind of medium-speed communications here. So if the wires are too long, you may have issues with the communicating with the battery, and if that's the case, you need to shorten your wires. We're going to go with this and see if this works. If it doesn't work, we will shorten the wires up. Now, I have neater ways of doing this. I'm not going to go into all the trouble and the time to do this, but I've got heat shrink and other things. But an easy way to do this is to just take these 2 leads, just kind of twist them together. You could probably leave them twisted like this, and it would probably work fine. But I'm going to throw a small bit of solder on these in order to secure them. It's got our soldering iron. Now, some people were asking about this soldering iron. This is a Hakko. It's an FX 951. This soldering iron is great. It's as light as a pencil. You can get all sorts of tips for it. I mean, the soldering iron's been out for several years. They have a newer model out now, but I like this one. I usually have it set at 320 degrees for most things. And this is my normal solder that I use. I pick up the silver bearing solder, which has 2.5% silver in it. I like this stuff. It makes things shiny. But 60-40 solder is perfectly fine too. Make sure you get the rosin core solder. You can get solid core solder, but the rosin in the middle helps clean the connection and adds flux to in order for the solder to flow. So you need to get some solder with some flux, and it's the common stuff. Usually you don't have to worry too much about it. Just going to put a little bit of solder on here. When you solder, you heat the wire up and put the solder on the wire as it's heated up. Don't put the blob, don't put a blob on the iron and just drip it on what you're trying to connect. That's what you call a cold solder joint, and the solder will just peel right off. So you want to make sure you heat the thing up that you're trying to solder and then apply solder. If the solder doesn't go on easily, touch it to the iron quickly to get the solder a little bit warm, and then continue by applying solder to what you're soldering, not directly to the iron. It's the proper way to solder so you don't end up with the cold solder joint. Okay, there are multiple ways you can deal with this, but it's good to keep this thing insulated. This is not the proper way as per se, but I've just got some tape here, and we're just going to provide a little bit of insulation on this connection so it does not short on anything. This is, hopefully I don't get any flack in the comments from this, but there are better ways to do this. You can use electrical tape, but I'm just going to throw some tape on there for now, and it'll hold together through our example. This is our +5. We'll come back to that later. That requires the resistor connectors. Next, we are going to deal with these two pins. There's one called enable and one called one wire. And it's two connections on this yellow connector. And we'll see it's the second one down from the top and the second one up from the bottom. And we'll notice there's 7 pins on here, but there's only 6 wires. Like I said before, the company that manufactured this device, for some reason or another, chose not to populate the first connection. So the first wire that we need is actually at the very top on this thing. So it is this wire. I'm going to follow this down. This is the wire. This is our enable pin, second from the top. And this needs to go into this. These two need to connect together. So let's connect these together. But we also need, if you notice, we also need to add this pull-up resistor into here also. So let's, okay. So I'm going to strip this back. And I lost it. So double check it. So make sure we get the right wire. And what I'm going to do for the pull-up is I'm going to twist these together here. And they are not wanting to really cooperate, but twist them together. So we're also double checking that we're on the correct wire for the Arduino. We're on D8, which is the top pin here, so we're on the correct pin. So I'm going to throw a little bit of solder on this wire to hold it together. Now also be cleaning your tip. You can use, before I got this fancy cleaner, I used a paper towel, a wet paper towel, to clean my tip as I soldered. So that works well too. Okay. And what I'm going to do is I'm going to kind of wrap this resistor around here. There's various ways you can do this, but I'm just going to do this, and this will work. Then I'm going to add a little more solder on here so that we have a stable connection. Okay, now that resistor is not going anywhere. Just like with the other connection, I know this is ugly. Let's go for it, but we're going to go for it with it for now. Leave it up to you guys to do a better job at this than I'm doing. Just going to insulate this wire. Now, we need to connect something to here, but we'll come to that in a minute. Let's connect up the other wire first. You'll notice that these resistors, these are not polarized components, meaning we can hook them backwards, forwards, we can hook them up either direction we need to. There are components that matter, but these components don't really have an issue with. Okay, so let's grab the second wire, which is the second one up from the connector. So we'll count 1, 2. We'll grab a hold of that wire. We'll trace it back to this connector. You notice it's the second pin down on this connector. So we'll grab that wire, and we'll do the same thing. Prep these wires for soldering. I mean, you could probably shove these wires directly in Arduino, but then you have to deal with how am I going to get the resistor in there. So there's multiple ways to go about this. This is just the way that I've chosen to do it today. There's not really a right way or wrong way, as well, I guess, as long as it works. Okay, same deal. Solder this guy up. I hope this thing is focusing. Not too much solder, just enough solder to kind of coat the wires. Same thing, we'll throw the resistor in. If I can figure out how to get the resistor to connect on. A little more details on the resistor. These are 1/4 watt, 5% resistors, but I mean, it's a detail that you really don't need to worry about. You can use 1/8 watt, 1/4 watt, 1 watt, 5 watts. It needs to be around a 5.6 or 4, well, these are 4.7s, 4.7, 5.6, somewhere around there. And I mean, you can use 5%, 1%, 2%. These are 5% resistors. And the meaning behind the 5% is that the value of the resistor is guaranteed to be within 5% plus or minus of 4.7K. Actually, I have tape here already. Okay. All right, so let's deal with the pull-up resistors. So this connection right here, you remember we saw this connection, this has 20 volts on it, which is, 20 volts is more than enough voltage to blow out this microcontroller. We don't want this 20 volts touching anything. We can either cut the wire off clean, or what I'm going to do is I'm going to just tape up the end of it so that it can't touch anything. Because I really do not want this wire touching anything. It will cause damage, short out, and other stuff. Another note is you could probably use this case. I've seen a lot of projects, do DIY projects these days, use these batteries as their power source. I mean, you can use the same type of thing, buy a cheap charger for to use as a donor, and take the connector off and use it to connect into your project. There's 20 volts on this wire, and you do need to size up these wires. These wires are not anywhere near the current carrying capacity needed for typical applications like these are. Okay, so we need to connect this to this. So both of these need to be connected, and how we're going to accomplish that is we're going to jump. So if we look at our schematic, again, what we have done is we have connected this line and this line, and we have hung this resistor out. We've also connected this ground wire. This ground wire is also connected. So, and you'll see on the schematic, if people aren't familiar, this little half circle, this is to indicate that the wire is jumping over this other wire. It's a common thing used on schematics. Some schematics just run it straight across. I like the method of putting this half circle shape out here so you know that the wire does not intersect. How you can tell a wire intersects is most generally there's a dot on the wire which shows that it's connected. So if it crosses like this and there's a big dot on it, all 4 wires are connected together. But like I said, I don't really care for that notation. I try very hard not to make crosses on my schematics because it can be confusing whether they're actually connected or not. Anyway, let's connect these 2 resistors up. So we need to connect these 2 together to the 5-volt line, and you'll notice they're going to be tied together. So we're going to jump these 2 resistors together, and we're going to do that with this white wire. I'm going to make this a little bit shorter. We don't need this quite so long. Actually, I see another way to do this. I'm not going to do that though. So I was thinking I could just tie them together like this and run them off like, no, I might do that. Now let's put the white wire in. Okay, so what I'm going to do is there's multiple ways to go about doing this. And the method I'm going to choose is to kind of shorten these resistor wires a little bit. And I'm going to use my needle nose to bend a hook in them. And it's going to make it easier for me to connect a wire up. So I'm just going to take these and just make a hook. And then I can connect a wire into that little hook, and it'll be a lot easier to solder together. So on this other connector, this wire is more flexible right now, but we can create the same kind of hook. And kind of hook that up. And we're going to give it a pinch just to temporarily hold it before we put solder on it. And it's going to stay put for a minute while we put solder on it. As soon as we solder it, it'll be secure and it won't come off. How did we do? Okay. Take a look here. So this is more of a close-up view. So that's what we did. So what I did is I created a small hook on there, and I looped the wire through and soldered it. And this wire does not need to be that long, so we're going to trim it. And we'll repeat it for the other resistor. So we'll just hook into that hook. We'll bend it. We'll use the needle nose to kind of bend the hook closed. And hopefully it stays long enough to get some solder on it. All right, That's good. That's good. Let's put a little more tape on those to cover up our connections. I really should be using electrical tape on here or something else. Ideally, I would use heat shrink, which is kind of a cool thing to have. It's a tube that you put over a solder connection, and you use a heat gun or you apply heat, either a lighter or heat gun, something else, and the thing in the tube will shrink in size with heat, and it's like taping it together for insulation, but it stays on much better. It's a lot neater. It doesn't have any of that sticky crap on it either that tape has on it. So what we're going to do with these is we're going to tie these together. Then we're going to jump them to this this positive wire coming off the microcontroller, off the Arduino. So let's trim these about the same size. So it's getting hard to follow because we're getting into a spaghetti mess of wires. I'm going to address these in a minute because we also do not want these things shorting. So we need to prep these for solder. We're just going to take the tip off. And now we're going to tie them together. And the reason is like I said in our schematic here, they're tied together here. And that is what this is here. So we're going to tie those together. Then we're going to take our microcontroller 5-volt line, and we're going to prep this. And tie it together. So this goes on here. If I can get it to loop around enough to stay still. Okay. Put a little bit of solder on there. I know you guys can hear the soldering iron beeping in the background, and essentially when I put the soldering iron in this holder, there's a switch on it which puts the iron to sleep, and it lowers the temperature of the iron to prolong the life of the tip on the iron. Then when I pick it up, it heats back up again and it beeps when it's up to temperature. So if you're curious what the beeping is in the background. Okay, same thing with this. We're going to put some tape on it. Make sure that that is nice and secure. Like I said, I honestly do not know the length of these wires. They're kind of long for the signal, but we'll just go with it and see how it works out. Okay, so so we have these wires left here. So what I'm going to do is these wires, they probably have signals on them. They're probably connected somewhere, and we do not want them willy-dilly dangling around and shorting out on stuff. It's possible something will get damaged, so we're going to just cut them off clean like this. And then I'm going to space them out a little bit like this. This is a trick you can use to wrap up wires. You'll notice that when I cut them off, there's barely anything. There's a little bit sticking out, but just to eliminate the possibility that these wires are going to short, I'm going to stagger them slightly, and then I'm going to tape them up here. And like I said, I should be using something like electrical tape for this, but we're just going to go with this. Okay, so with that, we should be done with the hardware assembly. And it took a little bit, and it looks like I will have to break this up into two videos. This video is getting a little bit long. I wanted to make one video uncut with everything in it, but it looks like we're coming up on the 50-minute mark here. So I think I'm going to have to end this video and we'll start up another video and deal with the software. But going back to what we have done. So we have our Arduino. We connected our Arduino up to this sacrificial connector. I know, no, the connector's not sacrificial. The charger came out are sacrificial. And I'm not going to plug this in quite yet. Yeah, sure, why not? So this is how this goes. If I plug this in, it's possible it's putting power into this Arduino right now. I highly doubt it because, like I said, they're open collector data lines. But it is making connection. It is making physical connection to the battery right now. So with that, I'm going to end this video and thank all you guys for watching. And stay tuned because as soon as I end this video, I'm going to start the next one and we're going to do the stuff on the computer. So thanks for watching. We will see you guys in a few minutes on the next video.